Hi, welcome to OpenLC Solutions. Today we're continuing our journey through the 2014 Ordinary Level Maths paper, and today we're going to move on to question 5, which is a calculus question. So we're given a function f, which is defined as x cubed plus 3x squared minus 9x plus 5, and we're asked to find the coordinates of the point where the graph of f cuts the y-axis. The thing about the y-axis is any point that's on the y-axis automatically has an x-coordinate of 0. So to find the coordinates of this point, we have to use this knowledge that the x-coordinate is 0, and so we're looking for f of 0. So the first thing is x cubed, so that's 0 cubed. We have a 3x squared, so that's 3 times 0 squared, a minus 9 times 0, and a plus 5. And all these zeros, of course, are going to cancel out, and so we're just left with a 5. In other words, the final coordinate is 0, 5. So we know the x-coordinate is 0, and we've just worked out that the y-coordinate is 5. We are then asked to verify that the graph of f cuts the x-axis at x equals 5. Now we already know that a point on the y-axis has an x-coordinate of 0. And in fact, it's also true that any point on the x-axis has a y-coordinate of 0. So what we're hoping to verify is that f of minus 5 equals 0. So we have to substitute a and x as minus 5 and see what we get. So f of minus 5 is going to be minus 5 that gets cubed plus 3 by minus 5 squared minus 9 by minus 5 plus a 5. So minus 5 cubed is going to be minus 125. Minus 5 squared is 25. Multiply that by 3, you get 75. Minus 9 by minus 5 is plus 45. And we still have this plus 5 trailing at the end. And so if you add all of this up, you should end up with a 0. And that's the verification that the graph of f cuts the x-axis at x equals minus 5, because when you put x as minus 5 in, you end up with the y-coordinate being 0. We move on to part B, which says to find the coordinates of the local maximum turning point and the local minimum turning point of this graph f. So the keywords here are maximum and minimum. And something that you should just know automatically is any time in functions or calculus that you're looking for a maximum or a minimum, what you're really saying is that the first derivative equals 0. So we first of all have to find the first derivative. And so we end up with 3x squared plus 6x minus 9. And to find the maximum and minimum turning points, we are saying that this equals 0. So now we have a quadratic equation with 3x squared plus 6x minus 9 equals 0. We're going to simplify this a little bit. So we've got x squared plus 2x minus 3 equals 0. Dividing everything by 3 gets you that. And you can do this by factorization or through the quadratic formula, but you'll end up with x plus 3 times x minus 1 equals 0. And so we have case number 1, where the first bracket, x plus 3 equals 0, in which case x has to be minus 3. And we have case 2, where the second one, x minus 1 equals 0, in which case x is plus 1. Now, those are the x-coordinates of the maximum and the minimum. We don't necessarily know which is a maximum and which is a minimum yet, but we can work it out based on the final heights of these points, which we have to get anyway because we need the total coordinates. We're not just asked about the x-coordinates here. So we need to work out what is f of minus 3, and we need to work out what is f of 1. Regardless of whether these are a maximum or a minimum, we still have to know what is the y-coordinate of these. And in fact, by doing that, by working out what is the y-coordinate, we can figure out which is the maximum, which is the minimum, because the maximum, as you would expect, is going to be higher up than the minimum. So this is going to be a minus 3 cubed plus 3 by minus 3 squared minus 9 by minus 3 plus a 5. So work through that. Minus 3 cubed is minus 27. Here we have minus 3 squared, which is 9. Multiply that by 3, you end up with 27. We have a minus 9 by minus 3, which is plus 27. And a plus 5 at the end. So that's going to turn out to be 32. So the final coordinates for this, minus 3, which we know is the x, and 32 turns out to be the y coordinate. Next we have to work out f of 1, so we're looking at 1 cubed plus 3 by 1 squared minus 9 by 1 plus 5. So that's a 1 plus 3 minus 9 plus 5. And so 1 plus 3 is 4, minus 9 is minus 5, plus 5 gets you 0. So you get 1, 0. And so which is the maximum, which is the minimum? Well, the 32 in this first coordinate indicates that it's higher up than the other one, and so you can imagine that it's going to be a maximum. So this one is the maximum, and this one is the minimum. So we have the coordinates of the local maximum, minus 332, and the local minimum is 1, 0. In part C then we're told, hence sketch the graph of the function f on the axes below. So to be able to sketch a graph you need to have some idea of the shape of it, which you usually get from the points or the slope of the graph. So up to now we've already worked out 4 points. We have 0, 5, minus 5, 0, minus 3, 32, which we know is a maximum, and 1, 0, which we know is a minimum. So we can put all of these on the graph. So 0, 5 is a point, minus 5, 0 is a point, minus 3, 32 is a point, so that's going to be a little bit above 30, maybe about there, and that's a maximum. And then we've got 1, 0 over here, which is a minimum. And so the graph, you should know that cubics will look either like this, or else kind of the opposite of that, which would be sort of like this. And hopefully with the points you have, you can tell the shape of it. You can also tell based on whether it's a plus x cubed or a minus x cubed. A plus x cubed is going to look like this, and this one is going to be a minus x cubed. So since our original function is a plus x cubed, we're looking at this top shape here. So we have to try and plot a shape like that. Remember, this minus 332 is a maximum, so we shouldn't have any points higher up than that locally. And likewise, as we go down here, we should end up with 1, 0 being the lowest. And from then on, it will climb up again. And beyond there, it can go above the maximum. That's why they use the phrase local maximum and local minimum, because it's just in that region you end up with the highest point and the lowest point. So this is approximately what the graph looks like. Based on the 4 points that we have, we know it'll have a shape similar to this, if it's not exactly that. So that is all of question 5 done. Thanks very much for watching, and hopefully I'll talk to you again in question 6.